All right, the first question on that page involves finding the factors of 24. Samantha, what does it mean if a number is a factor of 24?
It goes in 24 like 1 and 24.
Good. It goes in evenly. A factor of 24 will divide evenly into 24. No remainders. So that means something times that number equals 24. They got to be whole numbers. They have to be whole numbers. You can't say 0.5 times 48. They have to be whole numbers. Samantha, give me one factor pair for 24.
1 and 24.
1 and 24. So 1 times 24 and 1 and 24. Now, we're going to list 4 pairs. You can have them in any order. Justin, give me another one.
2 and 12.
2 and 12. Anna, give me another one.
3 and 8.
3 and 8. And last but not least, Abel, give me another one.
6 times
4. 6 times 4. Okay, so these are all the factors of 24. Normally, when you'll see it written, it'll be in numerical order. So it would probably be written like this. Did I get them all?
Yeah.
1, 2, 3, 4, 5, 6, 7. Okay, so normally if they were asked you to list all the factors, or if it said what are the factors of 24 and it was multiple choice and it showed you all these, piece of cake. But what if, Katie? What if you were taking a test and you didn't have access to your multiplication chart? You know what you could do, Katie? What? You could draw a multiplication chart. So if you had a test and you were looking through it and you found somewhere at the front or at the very back there were some blank pieces of paper that were perforated along the edge, you could kindly tear them out and draw a multiplication chart. You might want to do that as a warm-up to taking the test. So you kind of get your brain warmed up, and then later on when you need the multiplication chart, then your brain is more tired, and so you don't have to think as much then. You can refer to the multiplication chart. Questions on that problem? Excellent. I'm glad to hear you're here today. All right, the second problem says something that sounds similar to this. It has that chart. Stamp sets. Country, number of stamps. Germany 90, Sweden 78, Japan 63, Canada 25. And then it asks, says Dirk bought a set of stamps. The number of stamps in the set he bought is divisible by 2, 3, 5, 6, and 9. What set is it? So Dirk didn't buy all of these stamps. He bought one set of these stamps. And that set of stamps is divisible by 2, 3, 5, 6, and 9. So we're going to go over this one at a time. So one at a time. So, Reese, we're going to start with 2. Because if I can eliminate any that are not divisible by 2, then I'm making my chances of getting the answer greater. So, Reese, is 90 divisible by 2?
Yes.
How do you know?
Because it ends in a 0.
It ends in a 0. And if a number is divisible by 2, it ends in a 0, a 2, a 4, a 6, or an 8. Okay, so Germany is, we can't cross that off. Reese, is Sweden divisible by 2?
Yes.
Yes, because I just said if it ends in an 8, it's divisible by 2. Is Japan divisible by 2, Reese?
No.
No. Japan cannot be our answer. And is Canada divisible by 2?
No.
No. Now look what we just did. We've eliminated 2 answers just by checking if they're divisible by 2. Now what I'm going to tell you that I've seen in the past, Ethan, I've seen this in the past when people have questions like this. They'll go Germany and then they'll do all of these by Germany. Instead of just doing these one at a time, do the 2s, go through. Do the 3s, go through. And that way you're eliminating answers as you move through to make it much easier. So we know it's either Sweden or Germany that Dirk bought. Oh, let's see. Katie, let's look at 3. Let's look at 3. Now the good thing is you have access to these divisibility rules, but let's just say you don't. You don't. Okay, if you don't have access to the divisibility rules, you know how you could solve this? Just divide them in. Just divide them in. Okay, so, Ethan, do you know the divisibility rules for 3? They're in your journal. Get it out and read it. And Katie, you're going to tell me the divisibility rules for 5 in a moment. So you may want to jump ahead and look in your journal, table of contents. It says divisibility rules, and then you turn to that page. I don't have my journal because I got here late. I didn't bring my supplies. I went potty. So basically, I've not been in the room for 98% of your class today. As of right now. Excellent, Ethan. Ethan said, if you add all the digits together and they are a multiple of 9, then that number is divisible, or we're rewinding. If you add all the digits together and they're a multiple of 3, if 3 will divide into it evenly, then it is divisible by 3. So Ethan, what are the sum of 9 and 0? Yeah, 9 plus 0 is 9. Ethan, is 9 a multiple of 3? It is, but let's just say, Ethan, let's just say you didn't know if it was a multiple of 3. Well, one, you could see if 3 divided into 9, but know what else you could do? You could go to that multiplication chart that you wrote at the beginning of the test and look at that and see, look at all my multiples of 3 and just go down the 3 row. All right, so we can't cross off Germany yet. Sweden. Ethan, what's the sum of 7 and 8? 15, excellent. 15 is the sum of 7 and 8. Is 15 a multiple of 3? Yes, and you can look at your multiplication chart and see that. So I can't eliminate any of them. All right, the divisibility rules for 5, Katie. What's the divisibility rule for 5? Good. A number is divisible by 5 if it ends in a 5 or a 0. Thank you, Katie Logan. Katie, is 90 divisible by 5? Yes. Katie, is 78 divisible by 5? No. So I did 3 steps. 3 steps. And I got this answer. Instead of doing 90, 1, 2, 3, 4, 5 times, 78, 5 times, 63, 5 times, and 25, 5 times. Remember, work smart. I'm just saying. All right, so let's create some room over here. Let's put on my old man glasses. The next problem says there are 54 people attending a party. So we know there are 54 people. I'm sure you have this underlined, circled, highlighted in blood, or something on your test. And then it says, Carla's arranging chairs and tables. How should she arrange the chairs so there will be an equal number of people seated at each table? And so A, we have 12 chairs. B, we have 8 chairs. C, we have 9 chairs. And D, we have 10 chairs. All right, so we have 54 people. We want the same number of chairs at each table. With none left over. They don't want an empty seat. They don't want an empty seat because then they have to do more dishes and it's horrible. So we want none left over. So I'm certain on your paper you've underlined or circled or highlighted in blood. You've written down some things to jog your memory as you're solving it. Now, Markel, you think you know the answer?
Yep.
Which answer do you think is the correct answer?
C.
C. Why C?
Because I multiplied 9 by 6.
Because you multiplied 9 by 6. So 9 is the only thing that would divide into 54 evenly. 12 doesn't go into 54 evenly. No. 8 doesn't go into 54 evenly. No. 9 does. And 10 does not. Okay? Piece of cake. Not literally a piece of cake because you don't want to have cake for breakfast. Well, I do, but I'm old and don't care about my health, so it doesn't matter. All right, let's look at the next problem. Jake organizes 48 marbles into packs. So we have 48 marbles. And I'm sure you've circled, highlighted, underlined, covered in blood. He places the same number of marbles in each pack. So the same number in each pack. I'm certain you've highlighted, circled, underlined, covered in blood. How can he arrange them? Okay, so we have answer choice A has 8 or 10. 8 or 10 marbles. B has 9 or 12. C has 10 or 12. And D has 8 or 12. Now, what is this problem basically saying, Jenna? Can you summarize it in your own words, maybe? Excellent, thank you. Jenna just used sign language to convey to me what this problem basically says. And what it says is, these numbers, if you want the correct answer, these numbers must both divide into 48 evenly. Because we don't want to have an extra marble over there. Because if you go into the store and you buy the marbles that Jake is putting out there, you don't want to say, I'll take that box, and you only have like one marble in it. You'd be cheated. Okay, so Jenna, does 8 go into 48? Yes. Does 10 go into 48? No, can't be our answer, Jenna. So if you circled A, that's wrong. Cross it off. Just cross off the answer choices we know are incorrect. Jenna, does 9 go into 48? No. Now, if you didn't know, you could always refer back to that multiplication chart that you drew. Jenna, does 10 go into 48? No. Jenna, does 8 go into 48? How many times? 6. Excellent. Does 12 go into 48? How many times? 4. Excellent. So then our correct answer would therefore then, in certain situation, become D. And these are finding common factors, basically. We're finding factors of a number. Okay, we had to find factors of 48. We didn't have to find all of them. We just had to determine which of those numbers is a factor of 48. All right, the next one. Oh. Let's go. All right. We're going to jump out to the top of the next column because the rest on that side are fairly simple. They're similar to what we've done. So tell whether 51 is prime or composite. 51 prime or composite. Is 51 divisible by 2? Is 51 divisible? I spelled that wrong, didn't I? Divisible by 3. All right. So, Brock, is 51 divisible by 2? No, it's not. No, it's not. Because it doesn't end in a 0, 2, 4, 6, or 8. Brock, is 51 divisible by 3?
No.
Excellent. Yes, it is. Because the sum of, yes, it is. Because the sum of 5 and 1 is 5 plus 1, which equals 6. And 3 is a multiple of 6. Great job, Brock. So, yes, it is. Therefore, Brock, is it prime or composite? Composite. Because we already know the factors of 51. We know that are 1 and 51 and 3 times 17. Now I'm going to tell you the ones that trick you up the most. The ones that are going to trick you up the most as far as thinking if they're prime or not when you don't have your chart is 51 and 39. Those are going to be the ones that trick people the most. If I want to guarantee to get half of the kids to get an answer on a test wrong, that I don't let you use the formula chart, I'll just put is 39 prime or composite. And I'm going to get half of you to say it's composite. Because you're not looking at the rule, or prime, because you're not looking at the rules. It is composite. And 51's the same way. But if you think of the rules or do the division, then it's easy. Then it's easy.
59 was composite?
No, I said 39.
Oh.
39 is composite.
Okay.
Because 3 and 13. That's what tricks you up, because 13 is one that goes in there. All right, let's look at the next one.
I know.
Tala's locker combination consists of 3 prime numbers. So A is 3, 8, 17. B is 2, 3, 19. C is 7, 13, 3. And D is 11, 2, 5. And we must have 3 prime numbers. Okay, and I know you've circled, underlined, highlighted in blood 3 prime numbers. And the sum of the numbers is also prime. And I know you've circled this, underlined it, highlighted it, covered in blood, one of those 9 things that I asked you to do. So Ryan, let's look at this problem. Ryan, does A have only prime numbers? Is 3 prime? Is 8 prime? No. So A cannot be our answer. Ryan, let's look at B. Is 2 prime? 3 prime? 19 prime? Okay, so that's a possibility. C is 7 prime? 13 prime? 3 prime? That's a possible answer. D is 11 prime? 2 prime? 5 prime? Okay, so that's a possible answer. We've eliminated 1 just by figuring out which locker combination is not all prime.
It's big.
All right, so now we have to find the sum of the numbers. So let's find the sum of this. Ryan, what's 2 plus 3? 5. And what's 5 plus 19? 24. Is 24 a prime number? No. It's even, so it's divisible by 2. I can eliminate it right away. 7 plus 13, Ryan. Good. 20. And 20 plus 3 is? 23. Is 23 a prime number? Yes. I think my answer is C. Let's check D. Ryan, 11 plus 2. 13 plus 5. 18. Is 18 a prime number? No. All right, so very easy, and yet I still saw people miss this one because it took 2 steps. If you just cross off the ones that aren't prime, okay, that makes it much easier. You eliminate 1, and you increase your chances of getting it correct by 25%, just by eliminating 1 answer choice. Oh, let's look at the next one. A certain number is a whole number. If the number is also composite, what must be true about the number? Okay, so let's look at answer choice A. We want to see if what the answer choice says is true about every composite number. If it's true about every composite number, Liliana, is every composite number odd? No. 91's not odd. 91 is odd, but 13 is odd, and those are both prime numbers. Okay, and we're looking for a rule that applies to every odd number. Is every odd number have more than 2 factors, Liliana? Does every composite number have more than 2 factors? Yes, every composite number has more than 2 factors. So we think the answer is B. Let's check the other ones. Does every composite number have exactly 2 factors? No, because we just said it has more than. And does every composite number have 2 digits? No. 9's a composite number, it only has 1 digit. 6 is a composite number, it only has 1 digit. So every composite number has more than 2 factors. More than just one in itself. So the answer to that one would be B. Would be B. All right. The sum of 3 prime numbers is 12. What could the numbers be? Very easy. Very similar to the Locker combination one. The only one, let's see. We can eliminate B and we can eliminate D because they don't have just prime numbers in there. B has 6. 6 is not prime. 0 is neither. And D has 4. 4 is not prime. Which answer did you get, Reese? A. She got A, which was 3, 7, and 2. All 3 answers are prime. Reese, 3 plus 7 is? 10 plus 2 is? You're right, 10 plus 2 is? 12. And that's what it says. The sum of 3 numbers, 3 prime numbers, is 12. Questions on any of the other ones I didn't do on that page? Okay, they're all basically the same type of problem. Yesterday we went over order of operations. Today we went over prime, composite, factors, multiples, some such, and stuff like that. Now, from this point on, for the rest of your life, you should never, and the rock means never, miss problems that are order of operations or problems that involve prime, composite, or factors. Okay? So if we were to take a test sometime, that probably would be maybe 5 questions that you should automatically get right just by the 2 days of what we've covered. Just by the 2 days of what we covered. And really, Samantha, if you think about the test that I'm vaguely referring to because I don't like it, I think it's dumb and I don't want to say the name, but if you're thinking of that test, you're aiming, all you have to get is 60%. That's all you have to get. Now, obviously, we want to do better than 60%. But if you get 60%, you don't have to take it that second time. And you're golden. That guarantees you don't have to attend summer school. Questions? Thank you very much, Gracie. I appreciate your hard work.